Hi everyone! This video is designed to help you learn how to translate words into math symbols and translate math symbols back into words. Translating words to symbols. Words can be translated into math symbols to form expressions and equations. The math symbols can also be translated back into words. Let's take a look at a few examples. For addition, the following words are keywords that usually will indicate that you will add. Things like plus, and, total of, all together, increased by, combined, add, sum, together, more than, added to, in all, or make. If you see those words, we usually know that we're going to take some numbers and add them. For subtraction, the following are key words that usually indicate subtraction. Things like subtract, gave, take away, decreased by, fewer, minus, shared, fewer than, less than, difference, and less. For multiplication, these keywords usually will indicate you need to multiply. Things like times, triple, double, product, multiplied by, of, increased by a factor, twice, and multiple. And then there's division. These keywords will help you know that you need to divide. Things like quotient of, per, ratio of, divided by, half, divisor, divided into, percent, and split up. Some of these words will tell you that you're looking for things to be equal. Is, are, were, was. Think about it when you say 2 times 3 is 6. Well, that means 2 times 3 is equal to 6. Will be, yields, or sold for. Sometimes words will indicate that you need to group symbols. These keywords will help you know that you need to group some of the numbers in your expression, and we'll use things like parentheses, braces, and brackets to do that. So things like the quantity of, twice the sum of, times the sum of, times the difference of, plus the difference of. When you see the quantity or the sum or difference, oftentimes you're going to see that you need to use parentheses or grouping symbols in your expressions. Now, writing algebraic expressions. There are many different ways that you can translate words into symbols or symbols into words. There's not one correct way, which probably makes most people who love math a little crazy. We like that one answer. So let's look at some examples here. If we're talking about the operation of addition, you might see things like add 3 to a number, or a number plus 3, or the sum of a number and 3 more than a number, or a number increased by 3. All 5 of those expressions, verbal expressions, can be translated to the same algebraic expression. They all mean a number, we're going to use the letter n to represent that number we don't know, plus 3. The operation subtraction. You might see things like subtract 12 from a number minus 12, the difference of a number and 12 less than a number decreased by 12, take away 12 from a number, or a number less 12. Notice that the 12 and the number switch places, oftentimes depending on the way that the verbal expression is written, but they're all translated to the same algebraic expression, x minus 12. That x could be any letter. It just represents some number we do not know. All right, when we're working in multiplication, you might see things like 2 times a number, 2 multiplied by a number, or the product of 2 and a number. All of them translate to the same thing. Now we could write it in different ways. 2m is the same thing as 2 times m. 2.m is the same thing as 2 times m, or 2xm is the same as 2 times m. You'll most likely see it written 2m in this case. And then we have the operation of division. You could have things like 6 divided into a number divided by 6, the quotient of a number and 6. And you may see it written one of these two ways. Remember that the fraction bar is also a division symbol. So a divided by 6 can be written with the division symbol or as a fraction. All right, now you try. Add 43 to a number n. We're going to translate that into symbols. First, we need to identify the keywords that help us know what operation we're going to use. Here, that keyword is add. And we're going to add 43 to n, which means we need to start with n and then add 43. All right, try this one. A number w decreased by 12. W we're using as our variable here. It was defined for us. Sometimes it will be and sometimes it won't. But the first thing we need to do is figure out what keyword will help us know what to do. And that keyword is decreased by. So we're going to start with the number w and we're going to decrease it or subtract by 12. All right, try this one. And remember, you can always pause the video to make sure you're on the right track. 8 less than a number y. First, we need to identify the keywords. In this case, it's less than. And for something to be less than, it means we got to have something first, right? I have 8 less than a number y, which means we need y first. Then we can take 8 less than that. All right, try this next problem. A number x divided into 25. So again, we're looking at what the keyword would be here, and that is divided into. X is going to go into 25, which means that 25 will be listed first, and it'll be divided by x. Remember, that can also be written as a fraction of 25 over x, because the fraction bar also represents division. Here's another one. 7 times a number e. Let's look for our keywords. That's times. Times indicates we're going to multiply. And when we multiply with a variable and a number, we write it with the variable first as a coefficient and then e. Without there being any operation between the two, we just understand it to mean multiplication. So 7e represents 7 times e. All right, how about this problem? Take away a number c from 16. Again, we identify the words that are important here to help us know what operation to use, and that's take away. But we're taking away c from 16, which means we need 16 first, so I can then take away c. All right, try this one. The difference of a number and 24. What's our keyword here? It's difference. Difference means to subtract. And when you see the words difference or sum or product or quotient at the beginning of an expression, typically that means we're going to go right in order. So if it's the difference of a number and 24, we'll put the number first and we'll subtract 24. Remember that in subtraction and division, order really matters. In addition and multiplication, we can use the commutative property to move numbers around, but those two properties that property does not hold for subtraction or division. So order is really important. Again, remember when writing expressions, asking for things like quotients, sums, or differences, you usually write the symbols in the order that they're listed in the problem. I didn't put products here because oftentimes the coefficient will go in front of the variable, and that doesn't necessarily translate the same way. Here's another one. The product of a number and 41. Product is our keyword. It means that we are going to multiply. And this is a perfect example of where we won't necessarily go in order, because the product of a number and 41 will be written with the 41 as the coefficient first, and then the number. I've chosen the letter K here to represent the number we don't know. You could have used any letter to represent that number. And again, remember that typically when you see the words product, quotient, sum, or difference, will go in order. But because of the way that we write multiplication, where the coefficient comes first, in this particular case, the 41 would come first. 41k is the way we represent 41 times k, or the product of a number and 41. Remember that multiplication is commutative. It lets us move those numbers around. So even though we would typically go in order, this is the standard way you'll see this written most often. Here's another opportunity for you to try it out. 13 more than a number. More than. That's our keywords. That means we're going to be adding. So we have to have a number first to take 13 more. So to have 13 more than a number, we write it in this order. J comes before 13. And again, I chose J randomly. It's just a variable that represents a number we don't know. All right, here's another one. A number less 49. Notice that it doesn't say less than, it just says less. So it's a number and less 49. All right, here's a quick summary of what we've learned about translating expressions. Translating expressions. Words can be translated into math symbols to form expressions and equations. The math symbols can also be translated back into words. Some common words that mean addition are some, more than, increased, or in all. Some common words that mean subtraction are difference, less than, or fewer, or even decreased. All of those words would indicate we subtract. Some common words that mean multiplication are product, double, triple, or twice something. When you double something, you're multiplying by 2. Some common words that mean division can be quotient, per, half. When you're taking half of something, you're dividing by 2. Some common words that mean equal are is, are, yields, was, were. And we know that because when we do a multiplication problem like 1 times 2 is 2, is means equal. And then some common words that will mean that you need to have a grouping symbol are quantity, twice the sum of, things like that. It'll remind you that you need to take that quantity first or find twice the sum of. So we'll take the sum first and then take twice that. Those are things that would indicate we've got grouping symbols to help us organize the order in which we operate on the numbers. And remember that when writing expressions, asking for things like sums, differences, products, or quotients, you usually write the symbols in the order that you see them in the verbal expression. But products and sums can sometimes be written in a different order because of the commutative property, allowing us to move them back and forth. Hope you guys got a brief overview of translating expressions and do a lot more practice making sure you've got this one down.